Okay, today we're looking at the activity from lesson 4.7. To start the lesson, we're being asked to compare or design experiments to compare students who take an online prep class or prep class with a teacher in a classroom. In the first design, we need to do a completely randomized design for the two. And this is pretty straightforward. We just take our 50 students, right? We give a random assignment, a simple heads or tails for each student, or 25 numbers generated on one group and the other, and we split them into two groups. For one group, they have an online prep course, and for the other, they have the teacher prep course. And at the end, we just compare. How did they do? So this is the arc in total. And for this unit, we want to be able to draw out this step-by-step process. Well, in addition to a completely randomized design, we can also look at what might happen if we have some different homogeneous groups. For example, if we had 30 juniors and 20 seniors who were taking the class. There's some concern that random assignments could put most of the seniors into one group or all the seniors into one group. And this, of course, would be a problem because it stands to reason that seniors would likely have a higher SAT scores, right? So then we couldn't compare as easily. So to mitigate this or to control for this, we can do a block design. In a block design, we take some heterogeneous grouping, in this case, all the juniors and seniors mixed, and we break them down into homogeneous groups. All the seniors together, all the juniors together. We then go through a random assignment process for each of those groups, right? Meaning 10 groups of seniors go into the online prep class, 10 groups of seniors go into the teacher prep class, and for the juniors, 15 and 15. We can compare scores, and then at the end, we can combine and compare scores, right? Controlling for this will allow us to see more clearly or predict more clearly what you would have happen. Now, if there is further concern around what would happen if all the students with high GPAs go into one treatment group, a potential way to control for the GPA would be to do a matched pair design. You pair the top two students and then the next two students and so on, having 25 pairs in total. For each pair, we would toss a coin, and if it lands on head, the first student in the pair goes online, tails, the teacher course, etc. And there we could again compare, having controlled for GPA. That would just assure that we had an even distribution of GPA between both groups. Now, this process, we're going to be asked to just describe it in this step-by-step fashion. So looking at just seeing our understanding, we have a YouTube advertisements promoting a specific presidential candidate. We're going to select 300. And for the first one, it wants us to compare 3 different advertisements. So we simply just take our 300 subjects, do a random assignment, right? Obviously, if it's 300, where each random assignment has 100 people, and they watch one of the ads. And then we compare the results of the effectiveness of those ads at the end. Now, if I'm looking at the randomized block design, right, we have 300 subjects. We then split those subjects along some criteria. It could be age, like one's older or younger, We could do party affiliation, right? Which political party are they attached to, right? Or we could do gender, etc. There's lots of options. But essentially, we have two groupings, older, younger. We do it a random assignment. Each grouping has 50. We then compare and combine at the end. So if you're doing blocks, right, you could say the reasoning for that, well, I imagine ads affects older and younger people differently. Pretty straightforward. And in this context, which might be preferable? Well, I imagine the block design is going to be preferable because it controls age as a confounding variable, right? So it eliminates that. So there's lower variability. This is very important, right? It means it's easier to determine which ad is more effective.